Hello, I'm Vaishali. Welcome you all to my channel. So today I'm discussing with you the new topic in the complex analysis. Okay, so complex analysis topic we have already started. Inside the complex analysis videos, I have explained you about the analytic function. First topic we discussed was analytic function. Inside this first topic, analytic function, we discussed about CR equations in polar form, and we discussed how we can say a function is analytic and where the function is analytic, and we discussed three questions based on these topics. After that, in the next video I discussed with you CR equation in first I discussed the CR equation in Cartesian form, and in second video I discussed with you CR equation in polar form and the question based on CR equation in polar form. Now today I'll discuss with you the third topic, which is the harmonic function. How we say the function is harmonic, okay, and which formula is required to prove that a given function is an harmonic function. And based on these definitions of harmonic function, then we move to the next topic, which is harmonic function. When we say a function is harmonic conjugate of another function, okay, what step is required, and after that we move to these two questions, solution of these two questions. Okay, so this all we discussed in today's video. If you feel my videos are helping you for your examination and you feel the videos are helping you in clearing your concepts, so please subscribe to my channel and share my videos with your classmates, okay, and post your feedback regarding my videos in the comment section below. Now moving to the harmonic function. I just read the definition and then I'll explain you the theorem and this definition both. Harmonic function. Any function x and y possessing continuous partial derivative. Any function x and y possessing the continuous partial derivatives of first and second order satisfy Laplace equation is called as harmonic function. It means if you have a function and the function is dependent on the variables x and y, and it has the partial derivatives in terms of x and y, and it satisfies the Laplace equation. So when it satisfies and the function satisfies the Laplace equation, such type of function is called as the harmonic function. Okay, so this is the theorem. Real and imaginary part of an analytic function. So first you should know what is a function and how we represented an analytic function. Fz. Fz is any analytic function which is represented by u plus iv, where we know u is a function of xy and v is also a function of xy, where you should know that this is the real function and this is the imaginary function. Okay, now we have to show that a function is analytic. We know that the function is analytic. Now we have to show that if it is harmonic or not. To show that if it is harmonic or not, it means u and v function should satisfy the Laplace equation. Okay, so it is here how we have to show. Now this is the proof. If fz is equals to u plus iv be as analytic function, then they satisfy, if they are analytic, they satisfy the Cauchy-Riemann equation. What are the Cauchy-Riemann equation? First Cauchy-Riemann equation, CR equation, is del u upon del x is equals to del v upon del y, and second Cauchy-Riemann equation or the CR equation is del u upon del y is equals to minus times of del v upon del x. Okay, I termed this one. Now since u and v are the real and imaginary part of an analytic function, therefore the partial derivatives of u and v of all ordered exist and they are continuous in nature. Okay, if they exist and they are continuous in nature, that means del u upon del x exists and del 2u upon del x square also exists. Then del v upon del y exists and del 2v upon del y square exists. So taking the equation 1, del u upon del x is equals to del v upon del y. Now I just derivate it with respect of x both the sides, so del 2u upon del x square is equals to del v upon del x del y. Okay, similarly we can do for del 2u upon del y square, which is equals to del 2v upon del y up into del x. Okay, so now if we add these two, so this will become del 2v upon del x del y plus del 2v del y del x del y square. Okay, and here it should be a minus sign. When we add these two, first and second, I'll get the value of del 2u upon del x square plus del 2u upon del y square as 0. Similarly, if I'll do for y square, I'll get del 2v upon del y square, del 2v upon del x square is equals to 0. So if the u and v satisfy these Laplace equation, then we say u, v are harmonic functions. U, v are called as harmonic functions. I hope this is clear. Now, if in the question they will ask you find the harmonic conjugate of a given harmonic function, what is the process? So it is written here. First we'll go through the definition and then to the theorem. Harmonic conjugate. Let u, which is a function of xy, be a harmonic function. We know that u is a harmonic function. It means u satisfy the Laplace equation. That should be in your mind. Then a function v is said to be harmonic conjugate. Then the function v is said to be the harmonic conjugate of u. If first v is also harmonic, that means v should also satisfy the Laplace equation, and after satisfying the Laplace equation, u and v should satisfy the CR equations. That means del 2u upon del x is equals to del v upon del y, and del 2v upon del x is equals to minus del u upon del y. It is a very small concept, but it is very important because such type of questions comes in your GATE exam also. Okay, so for conjugate we have to do things. U should be harmonic, then v should be harmonic, and u and v should simultaneously satisfy the CR equation. Then v is said to be harmonic conjugate of u. Okay, now the theorem is given. I'll just explain you. If fz, which is the function of u plus iv, is analytic in a domain D, it means fz is differentiable in a full domain, D, then v is harmonic of u. We have to show that v is the harmonic of u, or the converse of it is, this is an if and only if type of a theorem. Converse is, if v is harmonic, then function is a, if v is harmonic conjugate of u in a domain D, then function is a analytic function in a domain D. Okay, so both way we'll discuss. Proof. We take fz is an analytic function. If fz is an analytic function, that means u and v should satisfy the CR equation. Okay, we have written this. Now if we differentiate it both the side with respect of x and y, again we get del 2u upon del x square and del 2u upon del y square, which is equals to 0. Similarly, we can proceed it for v. So now the first part is over, that u is harmonic. So first part is proved that u is harmonic. Now moving to the next part. U and v are harmonic functions in D, and v is harmonic conjugate of u because u and v satisfy the CR equation. He is saying that if u and v are harmonic function and v is harmonic conjugate of u, then u and v must satisfy the CR equation. Now this is the first part of the theorem is end. Now this is the converse of the theorem. Now let v be the harmonic conjugate. Now we assume that here v is the harmonic conjugate of u. Then by the definition of a harmonic conjugate, what we know by the definition, that v is harmonic. Secondly, v and u satisfy the CR equations, and v and u satisfy the CR equation. As uv is harmonic, u is also harmonic, v is also harmonic. So by the definition of harmonic function, u and v partial derivatives exist of the first and second order, and all are continuous in nature, and this tells that the function is analytic. I hope this is clear. If the function is analytic, then u is harmonic, v is harmonic, and u and v satisfy the CR equation, then v is the harmonic conjugate of u. If v is the harmonic conjugate of u, then u and v satisfy the CR equations, v and u are harmonic, then we say the function is analytic. I hope this is clear. The converse of the theorem is clear. Now we'll do first question. Okay, and after completing this question, we'll move to the question number 2. Now see what is given the question number 1. Prove that u, which is equals to, I just write u is equals to x square minus y square, and v is equals to y upon x square plus y square are harmonic functions. So first part is we have to show that u and v are harmonic function. So to show u, v are harmonic function. So for that we have to satisfy the Laplace equation. That means we have to show del 2u upon del x square plus del 2u upon del y square equals to 0. and second del 2v upon del x square plus del 2v upon del y square equals to 0. We have to show this. Okay, so I am differentiating first with respect of x. U is equals to x square minus y square, so it will become del u upon del x, which is equals to minus 2x, and del 2u upon del x square is equals to 2. Similarly, del u upon del y is equals to minus 2y, and del 2u upon del y square is equals to minus 2. Now adding 1 and 2, we get 0. So u is harmonic. I hope this is clear that u is harmonic, how I have shown that u is harmonic. Now we have to move the other question part. V is equals to y upon x square plus y square. We have to show that v is also harmonic. So del v upon del x is equals to minus 2xy upon x square plus y square whole square. Okay, similarly del 2v upon, I have done directly, you just solve it properly. Del 2v upon del x square will become 6x square y minus 2y का cube upon x square plus y square की whole to the power 4. So this is del 2v upon del x square. Similarly, we will find del 2v upon del y square. Del 2v upon del y square is minus 6x square y plus 2y का cube upon x square plus y square whole 4. Okay, now adding these two, we get equals to 0. It implies v is harmonic function. So first part is over. Now we have to tell that they both are not conjugates of each other. It means we have to show the CR equation, whether they are satisfying the CR equation or not. Okay, so del u upon del x should be equals to del v upon del y. Del u upon del x का value we can find it from here. Del u upon del x is equals to 2x, and del v upon del y partially derivate with respect of y. Okay, x square minus y square upon x square plus y square whole square. Okay, so they both are not equal. We will not go for the second condition. We say u is v. We say v is not harmonic conjugate of u. Okay, so this is the question done. Now moving to the next question. What this question number 2 says. Question number 2. Define the harmonic function. This I already given you the definition. Show that this function is harmonic. So you have given u is equals to x to the power 4 minus 6 x square y square plus y to the power 4. We have to show this is harmonic. So that means we have to show it will satisfy the Laplace equation. Del 2u upon del x square and del 2u upon del y square is equals to 0. Okay. So now we'll differentiate it 2 times. Okay. So we differentiated del u upon del x, which is equals to 4x cube minus 6 to the 12 xy square. Then del 2u upon del x square is equals to del 2u upon del x square is equals to 12x square minus 12y square. Okay, 12x square minus 12y square, that is del 2u upon del x square. Now we have to find del u upon del y, which is equals to minus 6 to the 12 x square y plus 4y cube. Then del u upon del y square, del 2u upon del y square, which is equals to minus 2x square, and we put y as 1 plus 12y square. We got it like this. Now del 2u upon del x square plus del 2u upon del y square is equals to 0. Okay, it means u is harmonic in nature. We have finished the second part as well. Now moving to the third part. In third part they are saying also find the analytic function. Now here we have to find the analytic function. Third part of the question, they are asking you to find the analytic function. Okay, so u is given to us x to the power 4 minus 6x square y square plus y to the power 4. See, if given that function is analytic, In that case, we can directly apply the CR equation, and by the help of CR equation we can find the value of a function. This is called as the shortcut method or the trick. This is very small method. See, we know del u upon del x is equals to del v upon del y. Okay, so we differentiated 1 with respect of x, it become 4 x cube minus 12 x y square. Okay, so we can write it del v upon del y is equals to 4x cube minus 12x y square. Why we are looking for y? Because see, fz is equals to u plus iv, है ना. u we have as x to the power 4 minus 6 x square y square plus y to the power 4 plus I. We only require to find the value of v. So from here we can find the value of v when we integrate both sides of the equation. See what we'll get. Integrated v is equals to, we get integration with respect of y, so we get 4x cube y minus, it will become x y cube, 4x y cube plus a constant c. Okay, this is the value of v. Okay, now we'll put it here. 4x cube y minus 4xy cube. So this is the function of fz, which is equals to x to the power 4 minus 6 x square y square plus y to the power 4 plus I 4x cube y minus 4xy cube. See, x to the power 4 minus 6 x square y square plus y to the power 4 plus I 4x cube y minus I 4xy cube. Okay, and this will become the formula of x plus iy to the power 4 plus ic, and I write it like this: fz is equals to z to the power 4 plus ic, and this is your final answer. Third part finished. Okay, so in this video I have explained you what is the harmonic function. Okay, what is the harmonic conjugate, question number 1 and question number 2. If you feel the videos are helpful for you, so please subscribe to my channel and share my videos with your classmates. Till then, goodbye and take care, and thanks for watching my videos.